So questions 7.1, reflection at a spherical surface. So our main focus is a spherical surface, okay, in our syllabus. So use the mirror equations, 1 over f equals to 1 over u plus 1 over v equals to 2 over r for real objects only. So in your syllabus, we're just going to focus on real object. That's what I told you just now. If you have m, then from m, you should be able to tell what happens to v, whether your v is positive or negative value, if you have the values of m. So define and use magnifications m equals to hi over h naught equals to negative v over u. Remember, m can give you a lot of information. The sign conventions will tell you whether the object is real or virtual. The image, sorry, will tell you the image whether it's real or virtual. And then it will tell you whether your image is upright or inverted. And also it will tell you whether the image form is same size as the object, magnify or diminish. Okay, all these informations can be obtained by just looking at M. All right, now let's look at example 1. Example 1, a dentist uses a small mirror attached to a thin rod to examine one of your teeth. When the tooth is 1.2 cm, in front of the mirror, the image form is 9.25 cm behind the mirror. So right here, you have what? You have positive U, but then this one, 9.25 cm behind the mirror. So this is negative V. Okay, this is negative V because it's behind the mirror. So you have a mirror and image is formed behind the mirror, behind a non-transparent object. So you have a negative, a virtual image. So determine the focal length of the mirror and state the type of the mirror used. So now you have equations 1 over f equals to 1 over u plus 1 over v. So 1 over f is equals to 1 over positive value. So positive 1.2 plus 1 over negative 9.25. Now, you can keep it in terms of cm. It's fine, okay? But if you use cm, then make sure all of them, they are all in cm. Your focal point or your focal length, your object distance, and the image distance, they are all in cm. Okay, if you use meter, then all of them must be in meter. So after you rearrange the equations, you will get f equals to positive 1.38 cm. Okay, positive 1.38 cm. So if your f is positive, then what type of mirror it is? So it is concave mirror. Okay, it is concave mirror. So you have concave mirror right here. So how do I know it is a concave mirror? By looking at the sign convention for f, because my f is positive. Okay, because f is positive, therefore it is a concave mirror. Then the magnifications of the image. So m is equals to negative v over u. It is equals to negative, and then negative 9.25 over 1.2. So negative, negative become positive. So positive 7.71. So by looking at this value itself, you know that now it becomes larger. Okay, it magnified. Okay, it's magnified, becomes larger. All right, so let's see example 2. Okay, so this question is just a very simple. Okay, 1 minute for you to write it down. Then we will look at example 2. Oh yeah, magnifications don't have unit, yeah. It's a dimensionless quantity. Okay, magnification is a dimensionless quantity. All right, example 2. An object is placed at 10 cm from a concave mirror with a radius of curvature 30 cm. Okay, so concave mirror means that this is positive R. Okay, positive R. And then is placed 10 cm from a concave mirror. Well, when it comes to our syllabus, we assume our object is always a real object. So this is positive U. So calculate the positions of the image for the object. So since now you're given the values in terms of R, now it is up to you whether you want to use equations 1 over U plus 1 over V equals to 2 over R, or you want to use the one with F. If you want to use the one with F, then you have to know that F is equals to R over 2. Okay, so kalau kamu nak kira F dulu pun boleh, tak ada masalah. Kalau tak nak kira, then you can use equations 1 over U plus 1 over V equals to 2 over R. Okay, then you plug in the value 1 over 10 plus 1 over V equals to 2 over 30. So V is equal to negative 30 cm. Okay, negative 30 cm. So negative 30 cm, next one, it asks you to state the characteristic. Okay, characteristic. So how are you going to describe it? You need to describe in terms of LOST. But right now, you don't know the size. Therefore, when it comes to stating the characteristic, what you have to do, you have to calculate the magnification. So M equals to negative V over U. So it is equals to negative 30 divided by 10. So you have M equals to positive 3. So now how am I going to describe it? Okay, the location, because my V is negative. So now I have it behind the mirror. Okay, behind the mirror. And then orientation, well, I have positive and positive magnification. Therefore, it is upright. Okay, it is upright. How about the size? Well, now if you look at this value, 3 is larger than 1. Okay, it's greater than 1. So it means that my image is now magnified. Okay, it's magnified. And then the type of the object, the type of the image, sorry. Okay, so the type of the image, you look at V. V is a negative value. Therefore, you have a virtual image. So that is how you state the characteristic without ray diagram. Okay, without ray diagram. By looking at the M and also the V. M and V will give you all of the characteristic. Okay, kalau kamu tak ada ray diagram, inilah cara yang kamu guna untuk tentukan dia punya characteristic. Alright, so this one I give you 2 minutes to write it down. Okay, 2 minutes to write it down, and then sendiri buat sikit catatan, sikit explanation on how to get the LOST in this question. All right. So next, example 3. Example 3, you need to sketch a diagram. Okay, would be better if you have a diagram to help you to imagine, visualize what is going on. So an upright image is formed. Okay, image is formed 20.5 cm from object. Image is formed 20.5 cm from the object, not from the mirror, by using a spherical mirror. The image height is 1/4 of the object height. So the key point here is the here and also the first statement. Okay, the one in a yellow highlight. So upright image is formed 20.5 cm from the real object. What does it mean? So you sketch a diagram. So this is a horizontal line. Okay, I have an object right here. And then this is my image. I don't know where is the mirror. Okay, I don't know where is the mirror. But what I do know right now is the distance between them is 20.5 cm. Okay, so I'm just going to assume. Okay, I'm just going to assume a mirror. It could be somewhere here. Okay, somewhere here. It could be. I don't know. Where is the mirror? Okay, or even if you don't want to put mirror, it doesn't matter. Okay, why? Because O and I right here, okay, I'm going to have the total. Okay, the total U plus modulus V is equals to 20.5 cm. Okay, yeah, so let's assume my mirror is somewhere here. Okay, my mirror is somewhere here. So this is the mirror. So this is my U, and then this would be my V. Okay, usually when it comes to this type of the questions, then that is the diagrams that you have. So U plus modulus V is equal to 20.5 cm. Okay, 20.5 cm. So where should the mirror be placed relative to the object? So other than this statement, okay, other than the one in the yellow highlight, the one in the green highlight, what can we say about it? Image height is 1/4 of the object height. So H image is equal to 1/4 H object. That is the meaning. Okay, that is the meanings of image height is 1/4 of object's height. So how are we going to solve this type of questions? So first of all, if you look at this equation, now the information that you have is here. This would be the first equation with 2 unknown. Next, we're going to try to form another equations with unknown U and V. Okay, but what is the information that we have? We have H. So try to ask yourself, which equations contain U, V, Hi, and H naught? Well, you have only one equations with that, which is M equals to Hi over H naught equals to negative V over U. So this is the part that we are going to use in this question because it has Hi, Ho, V, and U. And right now we need another equations with unknown V and U. Okay, given we have one equation with 2 unknowns already, we need one more equation. So in this case, now my Hi is 1/4 H naught. So 1/4 H naught over H naught equals to negative V over U. All right. So H and H, I can cancel it out. Okay, I can cancel it out. So what I have right here, okay, if I rearrange the equation, I have V equals to negative 0.25 U. This is my second equation. So now sub equations 2 into 1. Okay, sub 2 into 1. So U plus modulus negative 0.25 U equals to 20.5 cm. So U plus 0.25 U equals to 20.5. Okay, so my U is equal to 16.4 cm. So that is how you solve it. Okay, that is how you solve it. So the crucial part is that you have to know that U plus V is equal to 20.5 cm. Okay, U plus V is equal to 20.5 cm. And then Hi over H naught equals to negative V over U. That is the equations that we want to use. All right. Okay, So that is the answer for questions A. Okay, that is the answer for questions A. Now, questions B. Calculate the radius of curvature of mirror and describe the type of the mirror required. Okay, so basically now that you have a U, okay, then you can calculate the V. Okay, you have U, you can calculate V by using U equals to negative 0.2, V equals to negative 0.25 U. So U equals to 16.4 cm according to questions 1. And then V is equals to negative 0.25 U, which is equals to negative 0.25, 16.4. Okay, so it is equals to negative 4.1 cm. Okay, negative 4.1 cm. So to determine the radius of curvature, we have 2 over R equals to 1 over U plus 1 over V. So plug in the value, 2 over R equals to 1 over 16.4 plus 1 over negative 4.1. Okay, so R is then equals to negative 10.9 cm. So now you have a negative value right here. It means that this is a convex mirror. Okay, convex mirror. So negative sign, it tells you this is a convex mirror. So sketch the formations of the image. Okay, so convex mirror, you have only one answer. Okay, you have only one answer. So basically, you just sketch that diagram. Yeah, just let me crop the diagram. Okay, so basically that is the answer. So you just label U with a 16.4, and then your V is 4.1 cm. Okay, your V is 4.1 cm, and then this is your image. All right, so let us go through the questions again. So first of all, it tells you now you have an upright image. Now, actually, upright is also a keyword. Okay, because you have upright image, you know that your image is formed behind the mirror. Upright image is always a virtual image. Okay, virtual image means it's formed behind the mirror, and that is how I obtain this diagram. Okay, that is how I obtain this diagram. That is how I know that the mirror is located in between O and I. Okay, if you don't know what type of image you have, then there would be another possibility where this is your object. Okay, this is your object, and then this is your image, and then this is the mirror. Okay, it could be that case. But right now, because of the terms upright image, therefore I know that my mirror is in between. Okay, therefore I know that I have a virtual image because you have an upright image. Upright image is always a virtual image. Okay. So from questions A, once I know that mirror is located between object and image, okay, I obtain the first equation, which is U plus V equals to 20.5 cm. And V, I put a modulus here, okay, because you cannot have a negative sign, you cannot have a minus sign. If you have a minus sign, then you're not going to get 20.5 cm between image and object. All right, so U plus V equals to 20.5. So the relationship between HI and a object is 1 over 4. So by using equations for magnifications, you obtain another relationship, which is V equals to negative 0.25 U. Then you solve a simultaneous equations 1 and 2, and therefore you obtain U equals to 16.4. Once you have it, you then proceed to questions B. Okay, by using 2 over R equals to 1 over U plus 1 over V to determine the values of radius of curvature. And because of the negative sign, you know that this is a convex mirror. Okay, because when you have upright image, actually there are two possibilities. Okay, there are two possibilities. Either you have the image where O is located in front of the focal length, okay, less than your focal length, in front of a concave mirror, or you have a convex mirror. Ada dua case di mana Anda boleh dapat upright image, okay, upright image. So these two cases, okay, these two cases, this case and also this case, it will give you upright image. So the reasons why we want to know whether it is a convex or a concave mirror is so that we know which one is the right diagram, okay? So if you got a negative value, that means it is a convex mirror, and that is what happened right here. If you have a concave mirror, then that is what happened right here. All right, so yeah, that is how we solve it. And then the question C, you just sketch it, okay? You just sketch the diagram. So, okay, these questions, I give you a few minutes to write it down, especially on how to obtain this diagram. How do I know where should I put a mirror? Okay, where should I put a mirror? And what does it mean by the 20.5 cm? Okay, pelajar biasanya tak boleh jawab soalan ini sebab dia tak tahu di mana 20.5 cm and they don't know how to form the equation. So now you form the equations. Okay, you form the equations, you write it down. Okay, so focus more on the questions A. Questions A usually is a question that students cannot answer. Questions B is very simple. Question C, basically, it's the same for every cases. Once you know that it is convex mirror, then you have only one answer. All right, now let us discuss example 4. Okay, let's look at example 4. Example 4, a person of 1.6 meter height stands 0.6 meter from a surface of a hanging shiny globe in a garden. So shiny globe actually is it's something like a mirror. Okay, so you have a mirror. So what type of mirror it is? Well, it is a convex mirror. Okay, because your shining surface is on the right hand side. So this is a non-transparent end. Okay, so shiny surface on the other side. So if the diameter of the globe is 18 cm, where is the image of the persons relative to the surface of the globe? So how are we going to calculate it? First of all, we know that the R is equals to 18 cm, but because you have a convex mirror, okay, because you have a convex mirror, so it is a negative R, negative 18 cm. Okay, but because if you look at the questions again, everything's given is in terms of meter. So I'm going to change it to meter. So my R is equals to, the diameter of the globe. So it should be 9 cm. Sorry, my bad. So it is equals to negative 0.09 meter. Okay, negative 0.09 meter. So according to the questions given, now the person spent 0.6 meter, 0.6 meter from the surface of the globe. So your U is 0.6 meter. Okay, so U equals to 0.6 meter. R equals to negative 0.09. From here, you should be able to determine the positions of the image. So 2 over R equals to 1 over U plus 1 over V. So 2 over 0.09 equals to 1 over 0.6 plus 1 over V. Rearrange the equations, you obtain V equals to negative 0.042 meter. This question is to test whether you know that the shiny surface of the globe is acting as the convex mirror or not. Okay, if you understand, then you should be able to answer the question. Okay, the crucial point is whether you know R is a negative value or a positive value. Now let's look at the second question. How large is the person's image? So how large? When it's asking for size, then we look at equations M. So M equals to HO over HI, okay, image, over HO equals to negative V over U. You want the size of the image. So you're going to use H and HO in your equation. Okay, so once again, we're going to use this part of the equation because we don't have the magnification. But we do have the information about the distance, image distance and object distance. Therefore, we're going to use this part. So plug in the value, okay, plug in the value. So initially, the person is 1.6 meters. So HI over 1.6 equals to negative 0.042 over 0.6, okay, over 0.6. So image height is equals to 0.112 meter, okay, 0.112 meter. So what is the characteristic? So characteristic is formed behind the mirror. How do I know that it's behind? Because of negative V. Okay, so behind the mirror. And then the orientation, it is upright. How do I know? Because I have positive HI. So it is upright. And then the size, well, by looking at the original size and the image size, obviously it is diminished. Okay, it's diminished. And then the type of the image is virtual. Why virtual? Because negative V. Okay, because negative V. Now you see, by looking at all this value, I'm able to identify the characteristic of the image. Okay, the LOST of the image. So 1 minute for you to write it down. Then we will discuss the questions 5 quickly. Okay, I'm going to finish off the exercise for 7.1. And then after that, I will let you guys go. So 1 minute for you to write it down. All right, let us look at the last questions for today's sections. So example 5. Example 5, a concave mirror forms an image that is 3.5 meters in front of the mirror. So this statement itself, it gave us quite a lot of information, where concave mirror, it tells us now we have a positive F, and then it forms an image that is in front of the mirror. Image in front of the mirror, this is negative V. Okay, this is negative V. And then the height of the image, okay, the height of the object, sorry, the height of the object is 8 mm, and the height of its image is 40 cm. Okay, it's 40 cm. So we have a height object, HO, and then height image is HI. But the questions would be, my image is upright or inverted? Okay, upright or inverted. Upright or inverted. So you try to look at the mirror. Concave mirror with virtual image. Concave mirror with virtual image will tell us that, okay, let's see. You look at the ray diagram. So concave mirror with virtual image, we have only one case, okay, which is this one. So concave mirror and virtual image means that we have positive HI, upright image. Okay, upright image. So in this case, our HI is a positive value. Okay, so positive object, positive image. So calculate the position of the object from the pole of the mirror. So we want the object distance. We have H, we want to calculate U. So once again, we are going to use HI over H0 equals to negative V over U. Okay, so HI is 40 cm. 40 cm. Oh, I'm going to change everything into meter because now I have the one in meter, mm, and cm. So I'm going to make it standardized. So HI 40 cm 0.4 over H0, 8 times 10 to the power of negative 3 equals to negative 3.5 over U. Rearrange the equations. My U should be equals to 0.07 meter. Okay, so positive answer, positive value, right? And then the focal length is 1 over F equals to 1 over U plus 1 over V. So you plug in the value and eventually you should obtain a positive focal length, okay, a positive focal length where F is equals to 0.0687 meter. That is the answer. Okay, that is the answer. So sketch a ray diagram. So the ray diagram, basically you just sketch the diagram that I showed you just now. All right. So